Hello and welcome to this lab demonstration on implementing vSphere DRS clusters. After completing this lab video, you will be able to set up a vSphere DRS cluster. When you have multiple ESXi hosts, you want to balance the load among your hosts when an ESXi host is overloaded and its virtual machines face performance issues. You can use vMotion to manually move live virtual machines between ESXi hosts in a non-disruptive fashion. But wouldn't it be great if vSphere could take care about load distribution automatically so that you do not have to vMotion virtual machines on your own? Or at least give you some hints which virtual machine or virtual machines you should move to which other ESXi hosts. This is possible with vSphere DRS, the Distributed Resource Scheduler. DRS is a vSphere cluster feature like vSAN or vSphere HA high availability, and it relies on vMotion, so vMotion must be enabled for DRS to work in a cluster. Note that vSphere cluster features, including DRS, work best when the ESXi hosts within a cluster are as similar as possible, ideally completely identical. That includes the CPU and memory configuration, as well as access to the same shared storage. Another best practice when using DRS is to place virtual machine swap files in the virtual machine directory. This way, they are not stored on local disks and therefore do not have to be moved when virtual machines are vMotioned to another ESXi host. For this lab, you should know the vSphere client user interface, and you should be familiar with vSphere vMotion. In the first task of this lab exercise, we will create a cluster and enable the cluster for vSphere DRS. Then we will configure the vSphere DRS automation level and the migration threshold of the DRS cluster. We will choose manual for the automation level, and we will set the migration threshold to aggressive. In the next task, we will add 2 ESXi hosts to the DRS-enabled cluster. Then we will verify that the ESXi hosts in the DRS cluster have a VM kernel adapter that is enabled for vMotion. Next, we create a load imbalance. We will run 3 virtual machines on one of the 2 ESXi hosts, and we will create heavy load on 2 of the virtual machines. In the final task, we will verify proper vSphere DRS cluster functionality. We will check for DRS recommendations, apply the recommendations, and examine the resource utilization before and after applying the recommendations. I'm sure I provided you enough good reasons to watch the following video on implementing vSphere DRS clusters. Now, let's get started. We want to perform the configuration on vCenter server SA VCSA01, so the first step is to connect to this server. Then we log in as administrator at vSphere.local. So the first thing we have to do is to create the cluster. In the navigator pane, we have to go to Hosts and Clusters, and we want to create a new cluster within the ICM data center. Let me expand the ICM data center. So we see at the moment we have one folder, lab servers, and these are the 2 ESXi hosts that we have within this folder. So let's add a cluster to the data center. We right-click the ICM data center and we select New Cluster. Now we enter the name of our cluster. Let's call our cluster ICM Compute 01. We want to enable vSphere DRS on the cluster. So we activate this feature and then we click OK. In the navigator pane, we can see that the cluster was added. And in the right pane, it took us to the Configure tab and to the Cluster Quick Start. And in the Cluster Quick Start window here, we can see that the selected services show vSphere DRS. We could use this Quick Start wizard to move on with the additional steps such as adding hosts and configuring details of the cluster, but we want to do it manually. We don't want to use the Quick Start. So we are done with creating the cluster and enabling vSphere DRS on it. In the next task, we want to modify vSphere DRS settings. The cluster has to be selected in the navigation pane, which it is. We need to go to the Configure tab, where we are. And now, under Services, we select vSphere DRS. We can see that DRS is turned on. And now, to modify some of the settings, we click Edit. And now we can configure automation details. And it starts with the automation level. What is the automation level? Well, we have three options here: manual, partially automated, and fully automated. Manual means that vSphere DRS will only make suggestions for the initial placement of a virtual machine when you power on the virtual machine. And it will only provide recommendations for live virtual machine migrations. But you as the administrator have to decide whether or not you want to apply these recommendations. So as the name says, it's a manual process by the administrator. vSphere DRS is only making suggestions. Partially automated means that vSphere DRS itself decides on the initial placement of a virtual machine, but it will only offer recommendations for virtual machine migrations. Fully automated means that vSphere DRS will do both. It will take care of the initial placement of virtual machines, and it will migrate virtual machines if needed and considered useful. When does vSphere DRS suggest or perform a migration? First of all, it depends on the DRS scores of the virtual machines. But in addition, you can instruct DRS to be more or less aggressive in the migration of virtual machines that have a bad DRS score. And that brings us to the second option. But before we get there, we have to set our automation level. In our lab, we want to use manual. Now this is the migration threshold that I just talked about it. And you see it's a slider. Actually, you can set one of 5 levels. By default, it's level 3. And we can move the slider around to decide whether we want to be more on the conservative side or whether we want to have an aggressive mode. So level 1 means that DRS should be very conservative. It will migrate virtual machines less frequently, actually only when there is a strong need and when the expected level of improvement is rather high. On the other end, 5 means that vSphere DRS will migrate virtual machines more aggressively. It will move virtual machines more often, even when there isn't a strong need and only little improvement of the DRS score is expected. In our lab, we want to set it to level 5. Predictive DRS performs migrations ahead of time before reaching contention. The idea behind it is that when you vMotion virtual machines only when things get rough, you add to the stress because the vMotion process itself also requires resources. Predictive DRS learns about the resource utilization over time and can therefore predict upcoming issues and then act proactively by migrating virtual machines before we even get into a stressful situation. Predictive DRS requires vRealize Operations Manager for data collection and utilization analysis. We don't have vRealize Operations Manager in this lab, so we are not going to use it. So let's go ahead and click OK. And that finishes our tuning of vSphere DRS in our cluster. In the next task, we will add ESXi hosts to the cluster. And we want to add the two ESXi hosts that we currently see in the ICM data center in the lab servers folder. So it's SA ESXi01 and SA ESXi02. How do we add them to the cluster? We simply drag the ESXi host to the cluster. Now we have to confirm. So we click OK. And let me expand our cluster. So you can see that SA ESXi01 has been moved to the ICM Compute 01 cluster. Now let's do the same for the second ESXi host, SA ESXi02. And you can see that we have both ESXi hosts within this cluster now. DRS relies on vMotion, obviously, because that's the whole idea, that we want to move virtual machines to other ESXi hosts. So vMotion has to be enabled. Let's have a look whether vMotion is configured on these two ESXi hosts. So in the navigator pane, I select ESXi host SA ESXi01. Then I click the Configure tab and I have a look to the VM kernel adapters. And we can see that we have a VM kernel adapter VMK2. Let me click it. Its network label, so the name of the port group is vMotion, and the enabled services shows vMotion. So vMotion is enabled on this VM kernel adapter on ESXi host SA ESXi01. Now let's do the same for the second ESXi host. And again, we see that there is an adapter VMK2. It's in the same port group, and vMotion is the enabled service on this VM kernel adapter. Seems like we are ready to go. So let's move on to the next task, where we want to create a load imbalance now. And we will do that by starting 3 virtual machines. And even though DRS most likely will make different recommendations, we will put all 3 virtual machines onto ESXi server SA ESXi01. One of the virtual machines is already running. That's our virtual machine Win1002. So let's double check here in the summary tab. And yes, it is running on ESXi host SA ESXi01. Now we power on the other 2 virtual machines. One of them is Win1004. So I select this virtual machine in the navigation pane. I select power and click power on. And now you see that DRS makes recommendations on where to put that virtual machine. Remember, we are in manual mode. That's why we have to decide, and we just see these recommendations. If we had set the automation level to partially automated or fully automated, then DRS would have made that decision on its own. And you can see that the top suggestion or the top recommendation is to place that virtual machine on host SA ESXi02. But we also have another recommendation, so we can choose one of these 2, and that would be SA ESXi01. I guess it shows SA ESXi02 first, because currently no virtual machine is running on that ESXi host, while we are running one virtual machine on ESXi host SA ESXi01 already. At the end, it doesn't really matter, because we have enough resources at the moment. The existing virtual machine, Win1002, is completely happy about its resources, so it wouldn't be a problem to place this virtual machine that we are about to power on onto the same ESXi host. That's why we see both possibilities. And that's what we are going to do. We want to run all 3 virtual machines on the same ESXi host, so we select the second recommendation and we click OK. And we can see here in the summary tab of the virtual machine that it is running on SA ESXi 01. Now let's do the same for the third virtual machine, Win1006. We select it in the navigation pane, we select Power and click Power On. Again, DRS makes recommendations, and the two virtual machines that are currently running on ESXi host SA ESXi 01 are not yet stressing that ESXi host enough that DRS would not give us the option to run it there. The top recommendation is to run it on ESXi host SA ESXi 02 for obvious reasons. No virtual machine is currently running on this ESXi host. We have two virtual machines running on host SA ESXi 01, but nevertheless both options are okay, and we pick the second option so that all our three virtual machines are running on the same ESXi host. And we can verify that also from the ESXi host perspective when we click the host in the navigation pane and we then select the VMs tab. Sorry, I selected the wrong ESXi host. So actually we see that no virtual machines are running on ESXi host SA ESXi 02, but now let me correctly select SA ESXi 01, and we see that three virtual machines are running: Win1002, Win1004, and Win1006. So far, that's not a problem. The virtual machines don't have high needs in terms of CPU or memory, so everything is working fine. But we want to get into a situation where DRS will recommend to migrate one or more of the virtual machines to another ESXi host. And we will do that by starting a script on two of the virtual machines that increases the load. And what we have to do is we want to connect to these virtual machines, Win1002. We launch a web console. And now on the desktop of this virtual machine, we see this script which is called CPU busy. We right click the icon and then we select Open with Command Prompt. What this script does is it performs 10 million sign computations, and when it's done, it displays the amount of seconds it took to perform these computations. And this causes high CPU load. So let's go back to our vSphere client, and we want to do the same on virtual machine Win1004. So we open a web console, and again we start the script. We now created heavy CPU load on these two virtual machines, and remember, all the three virtual machines that we powered on are running on ESXi host SA ESXi 01 at the moment. The second host in our cluster, SA ESXi 02, has no active virtual machines at this point. So we are ready for the final task of this lab exercise. We now want to verify proper vSphere DRS cluster functionality. Let's go back to the vSphere client. And what we will do here is we will check whether we have some recommendations from DRS. We want to have a look at the DRS scores of the virtual machines. And if there are any recommendations, we will apply them and check whether the DRS scores improve based or after applying the recommendations, basically migrating some of the virtual machines. So in the navigator pane, we want to select our cluster. And now we click the Monitor tab. And under vSphere DRS, we can click Recommendations. and we already see 2 recommendations. DRS will make new recommendations every 5 minutes, so there is this button Run DRS Now. Let's click it, and that forces DRS to come up with a new suggestion or recommendation right away. And you see, depending on the current load on the cluster, the recommendations can differ in detail, but nevertheless, there are recommendations because we have high load on ESXi host SA ESXi01. We don't want to apply the recommendation right now. Let's first have a look at the Summary tab. And in here, there is the vSphere DRS pane at the right bottom. And we can see the cluster DRS score as well as virtual machine DRS scores. If you're not sure what is the difference or what does it mean, cluster DRS score or VM DRS score, note that there is this information icon. So when you click it, you get information about this entity. So it says what is the cluster DRS score, and it's the average DRS score of all the virtual machines in the cluster. And that is 11, which is pretty low. Remember, the higher a DRS score, the better. Now let me show you the VM DRS score. And the VRM DRS scores are shown in groups. That's what we can see below. We see how many VMs have a DRS score from 0 to 20%. How many VMs have a DRS score of 20 to 40%, and so on all the way up to 80 to 100%. A high DRS score means that the virtual machine is happy, it finds all the resources it needs. So in our case, all the 3 virtual machines suffer from bad DRS scores. And the scores are really bad. It's between 0 and 20%, so they are experiencing serious contention. How many DRS recommendations are shown? You see that we have a link here where it says DRS recommendations 2. And you see that we have a link down here to view all VMs. Let's click that link and see what happens. And this takes us to the Monitor tab, and within vSphere DRS to the VM DRS score. So now we see the DRS scores of our 3 VMs, and we can see that one of the VMs currently has a DRS score of 0, the other one 8 and the other one 9. These are really low values, so this indicates that there is a serious problem. Now, in the same tab under vSphere DRS, we can click CPU utilization, and this gives us an overview of the CPU utilization per ESXi host within our cluster. So down here we see that ESXi host SA ESXi02 has no VMs running at this time, therefore there is no CPU consumption by VMs. And on our ESXi host SA ESXi01, we can see 3 colored boxes. And each of them stands for one virtual machine. So when we move the mouse to one of these boxes and we click into it, then we get more details. So we see this is virtual machine Win1002, and we can see the consumed CPU and other values. And we can do that for all 3 of these boxes. Obviously on my screen there is a problem that it is shown outside the visible screen, but you get the idea. You get, or you can get, information about each virtual machine here. Now let's go back to the recommendations. So in the Monitor tab under vSphere DRS, we click Recommendations, and we see that we have 2 recommendations at this point in time. One of them is to migrate virtual machine Win1004 from ESXi host SA ESXi01 to the other ESXi host of our cluster, and then the same for virtual machine Win1006. We could click Run DRS Now again to have a new suggestion, but you see there is no change. we still have the same suggestions. So now let's apply these recommendations. Down here we have the button Apply Recommendations. So when we click on this button, then vSphere DRS starts migrating the virtual machines. And we can see that at the bottom in the recent tasks, that a migration of virtual machine Win10.06 is currently done. We are migrating live virtual machines. One of our ESXi hosts is under high CPU load, so the migration will take a little bit. The migrations have finished. The status shows completed. Let's run a new DRS analysis to see if any new suggestions, recommendations come up, and they don't. vSphere DRS suggested to move virtual machines. We applied that recommendation. So now everything is as good as it can be. No more recommendations. Let's have a look at the Summary tab. And in here to the vSphere DRS pane again. And we can see that the DRS score of the cluster significantly increased, and also the VM DRS scores improved quite a bit. Initially, all 3 virtual machines were in the worst possible category. They had a DRS score below 20. And now we have 1 virtual machine in the range of 20 to 40, and you see it just updated, so things stabilized. And 1 virtual machine is in the range between 20 and 40, and 2 virtual machines are in the range between 40 and 60. So the DRS scores improved quite a bit. In our lab, we only have 2 ESXi servers, and we are causing extremely high load by our scripts. So this is as good as it gets. If we had more servers, or if we would have more realistic load on the CPUs of our virtual machines, then the DRS scores would be even better. So let's have a look at the CPU utilization. So we go to Monitor, and under vSphere DRS, we click CPU utilization. And you see that this shows all 3 virtual machines still being running on ESXi host SA ESXi01. This is obviously not correct. So what we have to do in such a case is we refresh the screen. And now we can see that 1 virtual machine is running on ESXi host SA ESXi01. When I click into the colored box, we see that this is VM Win10.02, and on our second ESXi host we have Win10.04, and the tiny box at the end is VM Win10.06. Why is this box so small? Because the boxes represent the consumed CPU, and we don't run the script on virtual machine Win10.06, so you see it consumes very little CPU. So we can stop the scripts now. We have seen successful migrations. You see that the console here has been disconnected. That happened when the virtual machine got migrated. So let's simply refresh the screen. Now we are back here and we stop the script. We do the same on our second virtual machine. This one wasn't migrated, therefore the connection wasn't lost. And we stop the script here as well. We don't need the console sessions anymore, so we can close these. And actually, if we refresh the screen here, we will see that the CPU utilization gets lower. However, it takes some time for this to be reflected because we see the average for certain time intervals. But let me do it again. And we can already see that in this interval, the CPU utilization, at least on 1 virtual machine, was smaller. That's the one where I stopped the script first, VM Win10.04. And this is obviously the time interval during which we stopped the script. So some of the time was still very high CPU load. The remaining time should already be very low. So if we wait a little bit longer and refresh the screen, we should see very low CPU load on all three of the virtual machines. And here we go. Now we have very low load on both ESXi hosts, and we see that all three virtual machines have a very small CPU footprint. Okay, that wraps up the DRS configuration. And since we don't need it anymore, we will disable DRS on the cluster, just to show you how to do that. So you can select the cluster in the navigation pane, go to Settings, and then you click Edit, and up here you have this global switch to enable or disable DRS on the cluster. So we simply disable it and we click OK. Our configuration, the automation level, the migration thresholds and other settings are kept, are remembered. So if you want to turn DRS on for the cluster at a later point in time, you simply go in here and you re-enable DRS, and it will be up and running with the settings that we configured. So we turned it off, and that's what it also shows here. So in the Configure tab under Services, vSphere DRS, you do not only turn it on or off, but it also shows the current status. So we clearly see that DRS is now off. Congratulations! You have completed the Implementing vSphere DRS Cluster lab demonstration video. In the first task, we created a cluster and we enabled that cluster for vSphere DRS. Then, in the second task, we modified some settings of the DRS cluster. What we did is we set the automation level to manual, and we configured the migration threshold to the most aggressive option. The idea behind it was that we wanted to make sure that we do see recommendations in our lab. In a production environment, you would probably be more conservative. Then we added ESXi hosts to the cluster. So we dragged the ESXi hosts into our cluster ICM Compute 01. Then we made sure that both ESXi hosts are configured for vMotion. So we checked that there is a VM kernel adapter that has vMotion enabled. After that, we created a load imbalance. We started 3 virtual machines on the same ESXi host. And in addition, we started a CPU intensive script on 2 of the virtual machines. And then in the final task, we verified proper vSphere DRS cluster functionality, which means we had a look at the recommendations, we had a look at the DRS scores, we applied recommendations, then we verified that virtual machines got migrated, we verified that the DRS scores improved. After that, we stopped the script, and I also showed you how to disable DRS in a cluster. You now know how to use vSphere DRS to balance the load among the ESXi hosts within a cluster. In our lab, we set the migration threshold to the highest possible level so that virtual machine migrations are very likely. In a production environment, I would recommend to use a more conservative approach. Do not forget that live virtual machine migrations also require resources. So start with a less aggressive migration threshold. See how it works, and only if you see the need for more frequent migrations, increase the threshold. If you have lots of DRS migrations in your environment, consider using predictive DRS, so that you can proactively move virtual machines before contention occurs. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware World.